an article entitled Numerical Investigation of Energy Dissipation in Sudden Contraction. Now I wanted to presentation our articles. Our presentation is organized into four sections, which include introduction, materials and method, results and discussion, and conclusions. Introduction. As one of the critical issues for many hydraulic structures, kinetic energy of water flow must be dissipated by water control structures. If the flow energy is not reduced, downstream structures may be damaged or destroyed. Energy dissipation is proportional to the flow turbulence, and the contraction of flow can significantly decrease the energy. A sudden contraction in the flow passage will lead to hydraulic jump, which dissipates the destructive energy. Experiments and theoretical studies show that sealing basins, bed roughness, and screens have energy dissipation effects. Yasuda and Hager in 1995, Wu and Molinas 2005, Day and Ricard 2007, Jan and Chang 2009, Chakir 2003, Bozgush et al. 2007, Sadafon et al. 2015, studies on hydraulic jumping rectangular channel with a gradual contraction, employed screen with porosity of 40% and 50% and for fluid values between 2.5 and 8.5. Rajaratnam and Subramania in 1968, Herbrand in 1973, Bergman and Hager 1993, Alhamid 2004, and Metin et al. 2008 investigation the characteristic of a hydraulic jump and its type in diverging sealing basins with isthmus beds. Materials and method. Materials and method, including experimental model, including in this study a horizontal open channel flume 0.3 meter in width, 0.5 meter in depth, and with 5 meter length was adopted. The experimental facilities is located at the University of Maryland in Iran. The walls are made from plexiglass in order to provide good visibility. The inlet flow and flow depths were measured by two rotometers, which an absolute error of 2%. Supercritical flow conditions were generated using a sluice gate with a 1 cm thickness and a 2.6 cm opening with the distance of 1.5 meter away from the inlet of flow. In terms of building a sudden contraction in the flow path, panels were installed 1.5 meter from the sluice gate. This figure provides a detailed schematic representation of experimental flume, indicating measurement location. Simulation features. As a powerful computational fluid dynamics modeling software, Fluid3D can help engineers better understand made flow processes. In Fluid3D, free surfaces are modeled with the volume of fluid technique, which has all the recommended components for successful treatment of free surface present in equation as follows. Run the UI on run xj equals 0. And run UI on run ti plus rho UI times run UI on run xi minus run p on round xi plus round mu round ui and round xj minus round u prime j times u prime I plus rho gi. This equation for VOF equations. Boundary conditions. The boundary condition in figure show that the fluid domain meshing figures and boundary conditions. The fluid domain comprises the 7 components, including symmetry, inlet boundary volume flow rate, outlet boundary outflow, walls and bed wall, and upper section is symmetry. For calculate the upper and lower energy used from equation E0 and E1, and for criteria evaluation used from coefficient of determination. Coefficient determination and normalized root mean square error. Dimensional analysis. Effective parameter on energy dissipation in our models include Q, so means discharge, foot number, velocity, bed width, lens channel, upstream energy, downstream energy, Y0, upstream depths, Y1, downstream depths, Y critical depths, G acceleration gravity, rho specific mass, and etc. With Buckingham dimensional analysis method, dimensional analysis shown with these equations, and relative upstream and relative downstream energy dissipation function upstream fluid number. Results and discussions. This figure also shows a comparison of numerical and laboratory energy dissipation, and as can be seen from the figure, the numerical and laboratory data are in good agreement with numerical data. This figure clearly showed that the relative energy dissipation increase of discharge energy dissipation rate increase with the upstream foot number. With the increase of discharge rate, the foot value and flow velocity in the upstream increase. When the high velocity flow hits on the contraction elements, reversed flow and a hydraulic jump appears. In fact, the hydraulic jump can lead to air entrainment, energy dissipation, and low velocity flow. This figure A, related to upstream relative energy dissipation, and figure B, related to downstream relative energy dissipation versus upstream foot number. Squares related to experimental data and triangular shape in both figures related to numerical data. This figure also shows a comparison of numerical data and laboratory energy dissipation, and as can be seen from the figure, the numerical data and laboratory data are good agreement. Conclusions. This study aimed to investigate the energy dissipation of supercritical fluid under sudden contraction by numerical and experimental methods. In the present study, the VOF method was used to simulate free surface flow, and the RNG Epsilon method was selected for the turbulence model. The results showed that the fluid value upstream of the sudden contraction calculated by the numerical method has a positive correlation with the experimental data. The efficiency of a short contraction with a supercritical flow has a significant effect on the dissipation of destructive kinetic energy. To create a sudden contraction, wooden boxes with a thickness of 7.5 centimeters on both sides of the wall of the laboratory flume have been used. The results of laboratory and numerical data showed that with increasing the foot number of the upstream of the sudden contraction, the relative energy consumption of the upstream and downstream of the sudden contraction increased. Although the validation of numerical and laboratory data showed a very high correlation between numerical and laboratory data. Finally, thanks for your attentions.
Hello, good morning, ladies and gentlemen. My name is Rabi Mahmoud Musa from Federal University of Lafia, Nasarawa State, Nigeria, Department of Geography. The title of my paper is Guzolite Solid Waste Dumping Area, Soil Heavy Metal Compositions in Guzolite Northern Parts of Cyprus. The paper will be presented in this International Scientific and Vocational Studies Congress. Introduction. Solid waste can be explained as all waste arising from human activities that are normally solid and discarded as useless or unwanted materials by Curfew 2001. Solid waste is generated from residential, commercial, industrial, institutional, constructions, stroke demolitions materials, and municipal services, Richards and et al. 2009. Misuse of these constraints of solid waste are fine dust, metals, glasses, paper, cardboard, textiles, forced gravel, vegetable materials, plastic, rice hooks, ties, and can, according to Avrodak and et al. 2013. Waste also classified into biodegradable and non-biodegradable or organic and inorganic waste, which will be combustibles in contents. Continuously, waste generations occur virtually in all human activities such as agriculture, industrial, domestic affairs, and other things. And disposal of waste activities can cause variety of soil contamination problems, including the position of wasted, the positions of unwanted materials having high concentration of heavy metals on alluvial soils. Fergusky and Sewell's 1993. Due to this increasing number of industrial activities worldwide, heavy metals pollution of land and water is becoming globally important environmental, health, economic, and climate problems. Various strategies, including bioremediations and phytoremediations, normally employed to remove heavy metals from such soil sources and making them suitable for agricultural domestic purposes, as well as urban development strategies. Then, according to the CAN 2004, then the study area, the research constraint is a good old some dumping site. Geographically, they have the coordinate of latitude and longitude from the north to east, represent northern limit of most active part of Mediterranean Sea as a dumping location. Approximately is 45 kilometers, 28 miles north of Nicosia, capital city of Turkish Republic of Northern Cyprus, based on the Hotel and Etel 2009. This is the picture of the dumping site, which is on mountain materials is being deposited from domestic and industrial activities, where we make the study, and we employ the methodology as involve collections of soil samples from different points at the dumping site, data collected both in the field and from the laboratory analysis randomly. Sample collected is about 45 samples we have collected randomly at the range of 0 to 20 centimeter depths for making the actual contaminations of the soil in the entire surface. Among the biggest, the dumping site is among the biggest, which receives huge amount of solid waste and some sludge waste from domestic and industrial surface, as I said. And also they have different colors in the soil because of the burning activities and other human activities in the area. Some soils are reddish, some are blackish, in the other portion is ashes due to the burning activities. Effect of waste disposal at this dumping site were studied in the collected samples to get the contaminated and uncontaminated as a control zones, where samples at average distance about 10 to 15 meters. This table shows the examples of our sample. We have mentioned them as a sample number from 1 to 45, sample size, ID locations, depths is general depths 20 centimeter. Bags, we have leveling the bags from 1 A1 to B1 C1, A2 B2 C2, A3 B3 C3, continuously up to our 45 samples. We use some materials to collect the samples, such as handheld first light auger devices. We have hammer, polythene bags as our container, pen, paper, and permanent marker for leveling each samples. before moving to the laboratory for X-ray fluorescence analysis. Soil samples were collected using that agar and other things to harmonize them and putting them in an oven of about 70 degrees Celsius. Samples are mixed well, dried in an oven at temperature of 70 degrees Celsius for about 24 hours. Sieved with 600 matches to separate the other debris in the soil samples like rocks, plants, and other unwanted materials. Sample is further sieved with 150 micron mash to obtain further, the only further of the samples for the preparations in the laboratory. The further pressed under a very high pressure of 25 magnums per annum into a tablet as a pre-treatment done for SRF analysis were carried out to find the result of the particular soil. After did all the tests of SRF, then we have made some other tests like specific gravity tests, soil porosity tests, soil pH tests to measure the confections and the mass volume of the soil samples by using some other specific equipment like in soil specific gravity. We use the phycometer, balance beaking form, funnel, spoons, and dish, while in the fraction void to empty spaces in the materials we use the balance beaker, funnel, filter paper, stopwatch, that is chronograph meter to make the time specific time gravity, then in the pH to measure the acidity and alkalinity of the soil. To measure the acidity and alkalinity of the soil, the results. Following the results given, the result gives details of the elemental compositions of various soil samples collected from the Gudole dumping site as our case study. This method allowed the mineralogy of the materials to be determined by measuring the characteristics of fluorescent rays of each crystalline structural features. The elemental composition of X-ray fluorescent machines of each particular selected heavy metals in the research work follows. We use 3 metals as our case study: zinc, copper, lead, and cadmium detected from the soil samples. This is the result. Zinc, copper is predominantly. It is almost in all our samples. Lead in some samples, while cadmium we have detected in only 1 samples. The specific gravity result is fluctuating according to the table below, or the graph shows that there is a fluctuation in the soil porosity or soil specific gravity based on our samples from G1 to G45, and also it was determined in gram. Then soil porosity also is fluctuating based on the graph we have presented. This is the result, is fluctuating and also measured by time because we are using the stopwatch. Then this is the time. This is our G1 to G45 sample. Lastly, the soil pH, which determines the acidity and alkalinity of the soil, is also fluctuating in the samples, and the highest is not up to the 9.5 scales from G1 to G45. This is the result of other tests to determine the soil specific gravity, soil porosity, and the soil pH. Based on the analysis, X-ray fluorescence of the soil samples of Kudel's solid waste dumping site in the table 2 shows that the level of selected heavy metals concentration. The heavy metals selected are zinc, copper, as I said before, lead, and cadmium, were detected in a harmonized concentration almost in all samples, except cadmium is detected in only one soil sample, which is G16A6. And the result of SRF values are expressed as a mass concentration, therefore milligram per kilogram, which is equivalent to the ppm values after conversion. Then in the conclusion, relatively low-level air, water, and soil pollutions can easily interfere with wildlife population and natural vegetation cover, change in atmosphere, and contaminate the water. Also cause contamination in our homes and indicating hazard to the grazing animals in the area. Result point out need to monitor heavy metals content in content in meat and vegetables obtained from the area and market for human/animal consumptions. Also conclude that large amount of copper, zinc, lead, and cadmium found in the dumping sites. The industries play a very vital role in the whole economy of both local and urban areas as well as entire country. It will be important if the following proposed action are taken to protect life and properties of the people, depend on natural environmental resources such as crops around the area and using resources for their livelihood. This is very, very important. The environmental organizations and the government entirely, they have to monitor all the activities of light and heavy industries as a result of depositions of the unwanted materials to the environment. So in the nutshell, this is the main issues that we carry out in our paper, and it will look over for further research for the benefit of all. This is some references we have made after the review of some literatures and other things. Thank you very much. God bless.
Hello everyone, I'm Raza Noruzi from University of Tabriz. I'd like to give you a brief breakdown of my paper entitled Experimental Study of Energy Dissipation in Vertical Drops with Horizontal Screen Under supercritical follow that prepared by me and Professor Dr. Danish Faras. The purpose of this presentation is investigation the effect of drop with horizontal screen on energy dissipation under supercritical follow conditions. Let me start with some general information on drop and screens. Screens have been introduced by Rajaratnam and Harting, a new method as an effective energy dissipation in rivers and downstream of hydraulic structures. These structures are located perpendicular to the flow direction to impulse regime transformation by a hydraulic jump and consequently dissipate energy. Screens are commonly used downstream of drops to reduce energy. Also, vertical drops are commonly used as the structure to dissipate the energy of flow in rivers and open channels. This study combines drops with screens to achieve a higher performance in terms of energy dissipation. Several studies have been performed on the influence of hydraulic parameters of vertical drops with the subcritical upstream flow. Therefore, in the present study, the performance of vertical drops with screens under supercritical conditions upstream was studied to reduce excess energy flow downstream of drops. For this purpose, screen was used horizontally at the brink of drop. Horizontally at the brink of drop. This drop. Experiments were carried in a laboratory room with a length of 5 meters, width of 0.3 meters, and variable height of 0.45 to 0.7 meters with floors and walls made of plexiglass. You can see the schematic of the experimental setup that drops and screens. Flow was supplied by 2 pumps, each with a power of 450 liters per minute and adjusted by using the rotameter installed on the pump with plus or minus 2% accuracy. Glass boxes with a height of 0.50 meters have been used to create a drop structure in the channel. In addition, the screens included a multitude of circular openings, each with a diameter of 1 centimeter and with porosities of 40 and 50%. You can see the screens and opening of the circular of screens. This table shows the range of measured variables. Results. Following figure illustrates the comparison of relative energy dissipation of flow in plain vertical drops and vertical drops with horizontal screen under supercritical flow in upstream. The use of horizontal screens in this structure increases the relative energy dissipation compared to simple vertical drops. Also, comparison of plain vertical drop relative energy dissipation change with vertical drop come with screens indicate similar behavior for relative energy dissipation changes in both drops. It can be observed that by reducing the opening rate and consequently increasing the upstream flow number, At a constant relative critical depth, the relative energy dissipation in both plane drop and drop with horizontal screen increases. It can be observed that in constant Froude numbers, by increasing opening rate and increasing relative critical depth in both plane drop and drop with horizontal screen, relative energy dissipation decreases. Comparison of porosity of screens indicates the negligible effect of these parameters on relative energy dissipation. Also, by comparing these two figures, it can be shown that the effect of upstream Froude number on relative energy dissipation is greater than relative critical depth. In Table 2, the resulting nonlinear relationships are shown in this research for the dissipation of relative energy. The first relationship, considering all the parameters studied, but in two relationships regardless of the porosity of the screens. In conclusion, let me sum up my main points. The use of horizontal screens increases the dissipation of relative energy compared to the plain vertical drop. Increasing the relative critical depth in a Froude number and porosity of fixed screen reduces the relative energy dissipation. Increasing the Froude number at a relative critical depth and porosity of fixed screen increases the relative energy dissipation. The results of screen with different porosities showed that the porosity of screen has little effect on energy dissipation, and only the important parameter is the extent of the screen itself. That brings me to the end of my presentation. Thank you for your attention.
Hello, I'm Siamek Razzaq, and I'm going to present our research, which is an investigation of contaminants origins in natural water resources in Ahar Plain, northwest of Iran. Groundwater is the main water resources for inhabitants of the Ahar Basin, for drinking and agriculture, as well as for industry and mining. In research area, we have Sungun mine that located in near Ahar Basin. Investigation of origin of contaminants is the first step of groundwater management plan in order to having sustainable and healthy water supplies. For the first time in this study, the origins of pollutants in the Ahar Basin were investigated. In this research, conceptual models have been used to investigate the pollution in water resources and their possible sources in Ahar Plain. Conceptual models including common techniques in hydrogeochemistry studies, such as statistical techniques, graphical techniques, multivariate analysis, and geological survey. Airplane located in East Azerbaijan province, 110 kilometer northeast of Tabriz, is approx 1,000 square kilometers, and elevation in the study area varies from 1,220 to 3,123 meters high above sea level. The plain is drained by Ahar Chai and is embanked by Sattarkhan Dam, located to the west of the city of Ahar, as can be seen in the figure. The annual rainfall in the basin is 294 millimeters for the period of 1991 to 2016. The aquifer system is patchy and unconfined. Abstraction of groundwater in the study area is through wells, springs, and canal system. Transmissivity of the basin is ranged from 250 square meters per day in the western and center parts to 100 square meters per day near the outcrop around the plain. The estimated specific yield for the plain is at 3% to 5%. Ahar Plain, involving a wide range of formations such as evaporation, alluvial, volcanic, and metamorphic formations from Cretaceous to Quaternary, which this variety caused hydrochemical complexity in the study area. The study area involves 90 deep wells, 23 semi-deep wells, 99 springs, 41 canals. There are 27 sampled data taken from springs, canals, rivers, and wells at the study area, distributed over the entire region, as can be seen in figure. As can be seen from figure, the size of the circle shows the distribution of the chemical of groundwater in the plain, in which the circle size is relative to the quantity of total dissolved salts. The table displays statistical summary of hydrogeochemical characteristics in samples. Further results are displayed in figures which show that the study area is impacted by two sets of contaminations. First, nitrate. There are 7 samples that showed nitrate pollutions. Second, for arsenic, lead, and iron, there are 10, 11, and 9 samples respectively showed high concentrations of these trace elements. In this research, as mentioned in the introduction, conceptual models were employed. Conceptual models include common techniques in hydrogeochemistry studies. In this study, Pearson correlation, scatter diagrams were used for statistical analysis, Piper diagram and stiff diagram for graphical analysis, and finally, hierarchical cluster analysis and factor analysis for multivariate analysis. As can be seen in the table, according to the calculated correlations between elements, possible processes are: first, common trend of groundwater through flow direction due to the water-rock interaction. Second, the decline of water table in the basin due to over abstraction and the gradual loss of dilutions. And third, increasing residential time of groundwater and water rock interaction in low hydraulic conductivity area. According to the scatter diagram, through hydrochemical processes are detected that they are ion exchange and reverse ion exchange. Piper diagram results display that the zone in the study area comprise zone A as temporary hardness and zone E as mixing zone. The stiff diagram indicate the groundwater samples of this study area are from six diverse origins. Class 1 reverse ion exchange, Class 2 evaporate formation, Class 3 dolomite stone or mafic rock formation, Class 4 limestone origin, Class 5 acidic rock, Class 6 mixing origin. In this part, 4 clusters were created. Cluster 1 has a strong association with nitrate and arsenic concentrations. Cluster 2 has a strong association with nitrate and arsenic concentrations. Cluster 3 has a strong association with nitrate and arsenic concentrations too. And finally, cluster 4 doesn't have nitrate or arsenic contamination. According to the results of factor analysis, there is 4 factors. Factor 1 indicates first, water rock interactions. Second, a general trend for the solutions in groundwater at the study area. Third, nitrate concentration with anthropogenic origin increase through natural dissolution. In factor 2, the presence of sulfate, arsenic, and iron ions is indicative of sulfate mineral origin at high concentration of arsenic and iron. Factor 3 and 4 display the origin of high fluoride and lead is not associated with other ions and has special characteristics that need more investigations. Our aquifer is not deep and has low groundwater resistance time. Recharge areas of the aquifer comprise hard rock formations with minimum water rock interactions for the infiltrated water. High quality surface water through the plane is in interaction with groundwater, where the water cross contribute to recharging the aquifer in the eastern, northern, and southern parts of the plain, but the aquifer drains to water crosses at its western parts and thereby reduce its resistance time. In conclusion, due to the above results, nitrate concentration values are outcomes of the following intrinsic processes: nitrate concentration at the ground surface, amount of groundwater recharge at the surface, and the characteristics of aquifer media. The origins of arsenic and iron contaminants is geogenic and attributable to porphyry copper deposits which differ from that of nitrate. The origin of lead contaminants is geogenic. Lead loads show random behavior. Based on the results of this study, for having sustainable and healthy water resources in the study area, an effective management plan for controlling the abstraction of groundwater is vital, because the source of most pollution is in the plain is geogenic.
Hi everyone, thank you for being here today. Let me introduce myself. I am Sina Sadeghan, an assistant professor in Civil Engineering Department of University of Maraghe. If you need more communication, this is my email. Today I am going to talk about one of the environmental problems caused by groundwater over abstraction or over exploitation, land subsidence. In fact, our goal is not to measure subsidence. We are going to calculate an index to measure the potential of subsidence. We call this index Subsidence Vulnerability Index. Okay. The Alpri framework calculates this index by incorporating a set of data layers. As you can see, aquifer media, land use, pumping of groundwater, recharge, impact of aquifer thickness, fault distance, and water table decline. These data layers are employed in this equation to calculate SVI, which is an acronym for Subsidence Vulnerability Index. As you can see in these equations, ALPRIFT are 7 Alpri data layers. The R subscript represent the rate of data layers, and the W subscript represent the relative importance of data layers. Okay. You can see the weight of data layers here, and the rate of data layers are calculated through GIS processing. Okay. Here you can see the geographical map of the study area, Salmas Plain, located in northwest of Iran in West Azerbaijan province. This plain is composed of alluvial sediments. You can see the boundary of study area here. Now you can see the spatial distribution of 7 Alpri data layers. As I said, these data layers are prepared after GIS processing of data. This is aquifer media. The blue color represents the area with low vulnerability and the red color vice versa. Okay. Land use. This layer is prepared by remote sensing. As you can see, the red color represents the irrigated lands that have higher potential to subsidence. The next layer is pumping. This layer is important because it can trigger land subsidence. As you can see, there is a more pumping value in the center of the plane. Okay, then you can see aquifer recharge, impact of aquifer thickness, and fall distance. Finally, the last layer is water table decline. You can see the hotspot area which have higher value of water table decline per year. After preparing the incorporated data layers and using the prescribed weights, the subsidence vulnerability index SVI is calculated by using this equation. This figure shows the spatial distribution of SVI. The red colors represent the hotspot area. These areas should be considered in water resource planning and management. This figure shows the result of land subsidence through INSAR processing. We can name it measured subsidence. A comparison between the measured subsidence and SVI delineates some areas that have high vulnerability, but subsidence has not yet occurred. Please visually compare these results. Okay, my presentation ends here. This subject is our ongoing research activities, and you can also see some of our publications. Thank you.
Assalamu alaikum. My name is Sabah Majid Gondal. I am serving as an assistant professor in University of Engineering and Technology, Lahore, Pakistan. Today I am going to present relaxed equilibrium structures in three-component dusty plasmas. Of these discussions are self-organization, force-free magnetic field, governing equation, quadruple Beltrami equation, analytical structure, solution of quadruple Beltrami equation, numerical result, physical invariants for three-component dusty plasmas, Bernoulli equation, and summary. Self-organization. Self-organization is a process where a system reproduces itself in such a way that a purposeful order is achieved from randomness. Self-organizing systems are their own reasons and cause. They produce themselves. In a self-organizing system, new order emerges from the old system. The constrained magnetized or non-magnetized turbulent fluids also self-organize to order states. In many of the self-organizing systems, the order states are found to be remarkably robust in the sense that they remain relatively invariant and their properties do not depend upon the way the system is prepared. In plasma, self-organization can be described by hurricanes on Earth, great red spot on Jupiter, reverse Phil pinches, sparrow marks. Self-organization can also be explained by the variational principle, in which the magnetic energy of the system decays to its ground state, whereas the magnetic helicity of the system remains conserved. Magnetic helicity describes the structural complexity of the system. Force free magnetic. The ideal energy equation of motion can be described as, and the steady state condition is described as, whereas in the solar corona the magnetic field plays a dominant role, so the other forces are neglected and this equation reduces as, which we can further modify in this form, which is known as the Beltrami field. And the main characteristics of the Beltrami state can be described as, it is the eigenfunction of curl operator. It describes twisted, shear, spiral and helical structure formation aligned to its own vorticity. It is the self-organized state of a single fluid plasma. It describes no flow, force-free state, and the behavior parameter. The solution of Beltrami state can be described in the Cartesian coordinate system as along x, y, and z component, whereas the Bessel function model is used to describe the solution of the Beltrami state in cylindrical coordinate system, which can be reached as Goerning equation. In the present system, we are considering three-component plasma, which are the electron, ion, and dust particles, which are the negatively charged particles. These type of plasma are present in equation disk, in magnetosphere, in Jupiter magnetosphere, etc. There are many regions which can also be created in the laboratory. So now we will discuss the governing equation of these three-component plasma. The normalized microscopic evolution equation of these three components can be read as, whereas P E, P I, P D, Psi E, Psi I, and Psi D can be read as. The flow of electron, ion, and negatively charged particles can be represented as VE, VI, and VT. To normalize these equations, the dimensionless parameters are used as. Now taking the curl of these three equations, we get an equation which is the generalized flow of electron, flow of ion, flow of dust particles, and the magnetic field. But we have three equations, so to close the system we use the Ampere's law, which can be described as, in which Ni and Ne is the density ratio which satisfy the cosine neutrality condition, which can be read as. Now inserting the flow of the dust particle in this expression, we get electron, which is described as flow of ions. Now inserting the flow of ions in this expression, we get the flow of the electron. Finally, inserting the flow of the electron in this expression, we get the quadruple Beltrami state, in which A3, A2, A1 and A0 are the constant, which can be described as, which is the linear combination of four force-free magnetic fields which has distinct scale parameters or distinct characteristics rules, which can be read as. Now writing the operator as curl and adding these four equations, we get this expression where B is the sum of four magnetic fields. Solving this equation, we again get the quadruple Beltrami field. Now the values of constant A3, A2, A1 and A0 can be described in terms of the scale parameters. And the value of these scale parameters can be obtained from the general quartic equation, either all they are real or all are complex, which satisfy these conditions. This figure describes the characteristics of the scale parameter when the discriminant is smaller than 0, means we have two real scale parameters and two are a pair of complex candidates. This describes the characteristics of the quadruple characteristics root of the quadruple Beltrami equation, which are a function of Beltrami parameters A, B, and C. Solution of quadruple Beltrami equation. The quadruple Beltrami equation, which is the sum of four linear Beltrami fields in a Cartesian coordinate system, the solution of quadruple Beltrami equation can be reached as, now applying the boundary condition, we get these four relations, and now solving these four equations, we can find out the values of C1, C2, C3, C4, which can be reached as, whereas N1, N2, N3, N4, and D can be reached as. Numerical result. This figure describes the profile of magnetic field as a function of distance. When the Beltrami parameter A is equal to 1.10, B is equal to 0.0042, C is equal to 0.3, and the boundary conditions are described here, in which we have two real scale parameters and two are a pair of complex conjugates. This figure describes the magnetic field has the diamagnetic behavior. This figure describes the also describes the profile of magnetic field as a function of distance for the different Beltrami parameters. A is equal to 0.1, B is equal to 1.0042, C is equal to 0.003, and then boundary conditions are same. And this figure describes the paramagnetic behavior. And the characteristics root, again we have two real and two are a pair of complex conjugates. So these two figures shows that by changing the Beltrami parameter we can change the nature of the magnetic field, means when if they are transferred from the diamagnetic state to the paramagnetic. Physical invariants for three component plasma. The self-organized state can also motion. So in which one is the energy, um, electromagnetic energy, and H is the helicity of the electron, Hi is the helicity of ions, and Hb is helicity of the dust particles. So whereas the generalized vorticity can be read as, now solving this is the variation principle, now using the above equation in this expression, and whereas the values of constant is described here, we get the this relation, and we get these are also three relations. These are the similar as we have obtained earlier. Now inserting these three equations in the above equation, we get the Ampere's law, which can be read as. So this equation shows that using the variational principle, we can again get the self-organized state, which is similar as we have earlier discussed. Bernoulli equation. Now inserting the steady state condition in the vortex dynamic equation, we get these three relations, and integrating these equations we get these three relations where GE, GI, and GD is the integrating constant. Adding these three equations we get this relation, whereas GET can be described as and P can be described as, whereas VE, VI, VD is the flow of the plasma species, and the flow of the electron can be described as, and the flow of ion can be find out from this relation by inserting the flow of the electron, which we get as, whereas the flow of the dust particle can be obtained by inserting these two equations, which can be read as. Summary. So from this paper we can analyze that we get the formation of relaxed structure in three component dusty plasma with electron, ion, and negatively charged dust particles. The equation that describe the strong coupling between flow and magnetic field which are derived. Solving these equations simultaneously lead to the Beltrami state. The Beltrami parameter, which are the ratio of generalized vorticity to the flow, play a very important role in the formation of relaxed structure. When all the Beltrami parameters are distinct, the system attains a higher order Beltrami state known as quadruple Beltrami state. The four characteristics group give rise to four self-organized structures. It has been observed that all the four real characteristics groups are not attained for the present laboratory parameter, or the two real and two non-real characteristics groups can generate the diamagnetic and paramagnetic field configuration are generated by using the physical parameters of a dusty plasma that was developed in a laboratory. Under the topology constraint of magnetic helicity and magnetofluid energy, the higher order Beltrami state is also obtained using the variation principle. These are the references. This is the list of my publication for year 2020, and these are my further publications. Thank you very much.
Un saludo muy especial, soy Julian Sepúlveda Casadiego, investigador y director del Centro de Investigación en Agricultura y Biotecnología CIAP de la Escuela de Ciencias Agrícolas, Pecuarias y el Medio Ambiente CADMA de la Universidad Nacional Abierta y a Distancia UNAD en Colombia. En el día de hoy vamos a presentarles BioUNAD 2, un dispositivo multiparamétrico de calidad de agua en línea de bajo costo para la sostenibilidad ambiental, un proyecto de investigación, desarrollo e innovación. De parte de nuestro señor rector, el doctor Jaime Alberto Leal Afanador, rector de la Universidad Nacional Abierta a Distancia, y de nuestro señor decano de la Escuela de Ciencias Agrícolas, Pecuarias y el Medio Ambiente, queremos agradecer al Comité Científico y organizador del quinto International Scientific and Vocational Studies Congress Engineering Bilmes por su invitación a ser parte de este ejercicio de conversación en torno a la ciencia, la tecnología y la innovación. Queremos recordar que este ejercicio de investigación nace a partir de la interacción entre la comunidad en el departamento de Risaralda, en el municipio de Dos Quebradas, en la República de Colombia. Este ejercicio básicamente es un proceso de investigación participativa, un proyecto que no nace en un escritorio, sino un proyecto que nace desde la comunidad. Como pueden ver, la carta de motivación nace a partir de la solicitud de apoyo de la comunidad para conocer, para generar nuevos desarrollos, transferencias técnicas y metodológicas y participación en proyectos de cofinanciación de interés mutuo y que a su vez apoye el fortalecimiento del desarrollo tecnológico en la región a partir de la investigación participativa. Este es el ejercicio sobre el cual se mueve la dinámica de investigación que hoy está beneficiando a 412 usuarios y a 1.648 personas. Fase de información y consulta. Antecedentes. Situación presentada en el acueducto comunitario en el departamento de Risaralda, municipio de Dos Quebradas, en la República de Colombia. Presenta entonces esta fase de información y consulta que nace a partir de esa carta motivadora con nuestras comunidades. Encontramos entonces, cuando hicimos la verificación de este contexto, que tenemos dificultades de acceso por costos a dispositivos multiparamétricos en nuestros acueductos. Se encuentra baja prevención de la escorrentía de los suelos y de la sedimentación. Encontramos también dificultades de acceso a energía eléctrica en los aforos y baja garantía de acceso al agua potable en los aforos comunitarios. Esta imagen es una imagen del tanque de captura de agua en el acueducto comunitario. A partir de ese ejercicio de conversación con la comunidad, entonces nace el problema de investigación. El problema de investigación que identificamos es la baja implementación y masificación de dispositivos multiparamétricos y climatológicos por sus altos costos, debido a que sus precios oscilan entre los 4.5 millones de pesos colombianos y aún así no cuentan con sistemas integrados para la toma de decisiones en tiempo real. La pregunta de investigación entonces es, ¿se puede desarrollar un dispositivo multiparamétrico de calidad de agua en línea y de bajo costo que pueda ser implementado a corto plazo en las comunidades y sus acueductos? A continuación podemos observar la imagen 2, que es de elaboración propia del tanque de almacenamiento de agua del acueducto comunitario que vamos a intervenir con nuestro proyecto de investigación. Entonces nace el objetivo general. El objetivo general entonces es implementar un dispositivo multiparamétrico de calidad de agua de bajo costo para la sostenibilidad ambiental. Los objetivos específicos se mueven en el escenario 1. Diseñar un modelo de dispositivo multiparamétrico. 2. Programar un sistema de información para la gestión en línea de datos multiparamétricos. Y 3. Implementar un dispositivo multiparamétrico en un ambiente de prueba. Y por último, 4. Implementar un dispositivo multiparamétrico en un ambiente real. ¿Cuáles entonces han sido esas consideraciones y motivaciones que nos permiten desarrollar ese proyecto de investigación? Lo primero son el conocimiento de los objetivos de desarrollo sostenible, que va a basar el proyecto y es en el objetivo número 6 de agua limpia y saneamiento. Es importante considerar las motivaciones para desarrollar el proyecto que tiene que ver con las Naciones Unidas en cuanto a la disponibilidad del acceso a los servicios de agua y saneamiento e higiene es fundamental para luchar contra el COVID-19, preservar la salud y bienestar de millones de personas y este COVID no desaparecerá sin acceso a agua soluble para las personas que viven en situaciones de vulnerabilidad. Entendemos también que ONU Habitat en el 2020 nos indica que los efectos de la COVID-19 podrían llegar a ser considerablemente más graves sobre la población urbana, pobre que vive en los suburbios y que no tiene acceso a agua limpia, de tal manera que es peritorio iniciar y trabajar de manera asociada para generar estos accesos a agua corriente y especialmente al lavado de manos en entornos informales. Es entonces cuando la UNICEF en el 2020 nos dice que urgentemente debemos aunar a los fondos para ayudar a que lleguen a más niños y niñas con instalaciones básicas de agua, saneamiento y higiene, especialmente para aquellos dentro del abastecimiento de agua soluble no tienen en sus áreas remotas. Es importante también entender que la ONU en el 2020 nos dice que cada día debemos trabajar para que la higiene se multiplique a partir del ejercicio de agua soluble. Alrededor de 1.000 niños mueren debido a enfermedades diarreicas asociadas a la falta de higiene. 3 de cada 10 personas carecen de acceso a servicios de agua potable y 6 de cada 10 carecen de acceso a instalaciones de saneamiento gestionadas de forma segura. De tal manera que hemos desarrollado un estado de arte en la República de Colombia que nos permite a nosotros identificar metodologías de vigilancia, metodologías de aceptabilidad de muestras de agua, sistemas de información al servicio del saneamiento, especialmente de agua, en calidad de agua. Encontramos también instrumentos básicos para garantizar el agua de consumo humano, pero en todas estas líneas del estado de arte encontramos que el acceso en tiempo real a los dispositivos multiparamétricos de control de agua a partir de dispositivos electrónicos no son suficientes. En este momento Colombia no cuenta con dispositivos en tiempo real para tomar las decisiones en cuanto a la calidad de agua para el consumo humano. Es importante entonces, a partir de este ejercicio que presentamos anteriormente, encontrar un esquemático de prototipo propuesto que nos permita a nosotros dimensionar un sistema de información que dé respuesta a la pregunta de investigación y al estado de arte. Es por eso que el módulo multiparamétrico de sensores para la medición de calidad de agua debe ser un instrumento que permita medir a través de un único equipo diversas variables para el análisis de resultados de calidad de agua. Debe entonces estar equipado con sensores industriales de larga duración para la medición continua de las variables en estudio, permitiendo monitorear en tiempo real las condiciones de calidad de agua de manera continua, y un modo de energía fotovoltaica para medir, procesar y enviar datos a un servidor web con autonomía eléctrica. De esta manera, el esquemático propuesto tiene que ver con la fuente hídrica, con el manejo de los sensores, con una plataforma IoT del Internet de las Cosas, que es un nodo MCU de una plataforma Wi-Fi, un sistema de información para el procesamiento de datos y un sistema fotovoltaico a partir del uso de energía solar fotovoltaica. Para esta metodología utilizamos básicamente el desarrollo tecnológico de BioUnat. Se realizó empleando el método PMI, que es el Project Management Institute 2017, en donde se integran 5 grupos de procesos, a saber, GP, que se plantean que son el inicio, la planeación, la ejecución, el seguimiento y control y cierre, de tal forma que se logra definir el ciclo de vida del proyecto a partir de los grupos de procesos implicados, sus áreas de conocimiento en términos de gestión de la integración, gestión del alcance, gestión de la programación, gestión de los costes, gestión de la calidad, gestión de los recursos, gestión de las comunicaciones, gestión de los riesgos, gestión de las adquisiciones y gestión de los implicados. De tal manera que esta metodología de Project Management Institute nos permite a nosotros paralelamente generar un desarrollo de software, pero también desarrollo prototipado de hardware. Es por eso que este proyecto adapta el Project Management Institute como la guía de fundamentos en la dirección de proyectos PMBOK Git de esta edición. De tal manera que es importante mencionar, dentro del proceso de resultados hemos logrado el diseño, la programación e implementación de BioUnat 2, pues un dispositivo multiparamétrico de calidad de agua en línea de bajo costo, un dispositivo fotovoltaico versátil de lectura y gestión en línea de datos multiparamétricos de pH, oxígeno disuelto, sólidos disueltos, conductividad eléctrica, temperatura, con capacidad para gestionar más de 99 sensores e integra datos climatológicos y una autonomía de 55 horas. Observamos entonces en esta presentación a BioUnat 2, nuestro dispositivo multiparamétrico que contiene una sonda de pH, que es el potencial de hidrógeno, una sonda de ORP, de potencial de oxidación-reducción, una sonda galvánica de oxígeno disuelto, una sonda de conductividad eléctrica y un sensor de termoresistencia. También contiene un sistema de información en línea, un panel solar y el prototipo. Como conclusión, BioUnat 2 es un dispositivo multiparamétrico de calidad de agua en línea de bajo costo, no superior a $680, que garantiza el acceso a agua salubre. Es un resultado del proyecto tecnológico de investigación del Centro de Investigación en Agricultura y Biotecnología CIAP de la Universidad Nacional Abierta a Distancia, diseñado, programado e implementado para el uso de nuestras comunidades. Aquí tenemos una biografía, Atlas Scientific Conductivity Probe, Atlas Científica LabGrade DO Probe, tenemos el LabGrade DPH Probe y tenemos también el Project Management Institute en el Body Knowledge PMBOK, quinta edición. De parte de la Universidad Nacional Abierta a Distancia, queremos agradecer a todos por por su atención y esperamos vernos en un próximo congreso. Muchas gracias.